Today's lesson video, we're going to look at Physics 1501, May, June 2013, question 1. Let us start. This is the actual question paper. The mark allocation is 10 marks, so I assume that the mark allocation for question A, it will be 5, for B, it will be 5 also. So the scenario states that, or says that, an object is released from rest at the top of a cliff that is 150 meters above the ground. Assume air resistance is negligible and answer the following questions. Now, looking at the picture form of the scenario, we have a cliff which is actually 150 meters. And then the object was dropped to the ground. Now, the moment they say the object was dropped, so it simply means the object was not projected. So the initial velocity will be 0. And then we know that from, suppose this is point A, this is point B, from point A to point B, this ball will travel, or this object will travel at a certain time. Then the displacement will be 150 meters, and then we also have V final at this point, and then we have the gravitational acceleration, which is 9.8 meters per second squared. This is the data that we have. Now the first question says, how long does the object take to fall to the ground? In order for us to actually answer the question, we need to be familiar with the equations of motion. We have 4 equations of motion. There is a lesson video whereby we discuss the equations of motion in detail. Now, looking at these equations of motion, we need to choose the suitable equation for this question. Now, selecting the first equation of motion, we don't have the final velocity. We have the initial velocity as 0 meters per second. We have A as 9.8 meters per second squared. We don't have time, and we are actually looking for time. So we cannot use this equation because we have 2 unknowns. Looking at the second equation, we have the final velocity. We actually don't have the final velocity. We have the initial. We have the 9.8 meters per second squared. We have the displacement. But remember the question, it says how long. So we are actually looking for the time it takes to move from point A to point B. Since this equation doesn't have the time as our physical quantity, so this equation is also out. Looking at the next one, we have the displacement as 150 meters. We have the initial velocity. We are looking for the time. We have the 9.8, and then actually this equation, there's a problem here. This is supposed to be time squared. We also have this. We're actually looking for this. So we can say this change in time and this one is the same thing. So we can actually use this equation. So this is the equation. We can just substitute and find the answer. So our displacement, it will be 150. It's equals to the initial velocity, it's 0. Change in time plus half 9.8, then change in time squared. So we have 150, it's equals to 0 multiplied by change in time, we actually have 0, plus half multiplied by 9.8, the answer is 4.9, change in time squared. Then from here we divide both sides by 4.9. This will result into 1 multiplied by change in time squared. We have change in time squared, it's equals to 150 divided by 4.9. So we need to remove the power 2. So we put the square of both sides. Even if you can put plus minus, remember that time cannot be negative. So we are going to consider the positive time. So change in time is equals to square root of 150 over 4.9. We have 5.533 seconds. So this is the first answer to the first part of the question. So how long it takes? 5.533 seconds. Now looking at the second question, it's saying what is the impact velocity of the object? So looking at our scenario again, it simply means that from here to here the time it takes is 5.533 seconds, and then the question says the impact velocity, so it's the final velocity. Going back to our equations of motion, we can see that we can actually use this one. Since we are looking for the final velocity, we have the initial, we have the 9.8, we also have time now, which is 5.533 seconds, or we can use this one. Now I prefer us to use this one, because if it happens that our solution for this one, whereby we must substitute change in time, it's not correct, then it means answering this question, it will also be incorrect. So looking at this equation, we can see that all the data that we are going to substitute, it's given from the scenario. So I prefer us to use this one. Even though we can use this one, the answers should be the same. So our final velocity is Vf squared is equals to our initial, it will be 0 plus 2 9.8, and then we have 150. And then we are going to have Vf squared is equals to 0 squared is 0. So we have 2 9.8 150. Then we need to take the square of both of these. Vf is equals to square root of 2 multiplied by 9.8 multiplied by 150. We are going to have 54.222 meters per second. So this is the impact velocity at point B. That's it for this lesson video. This is Wahula SJ. Thank you very much.